So this will be last talk for the day. It's going to be a talk called Python plus geographic data equals to BFFs. Please give a hand for Mele Sax-Barnett.
There is the fabulous bit.ly link to my talk, including everything that I'm not going to have time to say in Markdown format. So there's that for your reference. Thank you for hanging out till the end of the day. I'm really excited to share this with you. So why do I think Python and geographic data are going to be best friends forever? Well, I love maps, but making them can be a real pain. And the reason is, well, cartographers don't just trace stuff anymore. You have to deal with the data. And that can be really, really, really awful. It is usually not in the format that you need. There's like 100 different formats at least. Several obvious errors. Everyone with some bad data has created their own null island at some point. Split up into 50 different files, and is definitely in the wrong projection. So sometimes you even have no metadata, so you don't know what projection it's in, what encoding it's in. It can be pretty awful. So you can point and click all day in your out-of-the-box GIS software, or you can bring Python into the mix. So a little bit about vector geodata before we get started. It can be made up of one or several files. It will have a coordinate system or projection associated with it to show how the round Earth ends up on a flat surface. It can be made up of one or several layers of data, each of which has one or more features. And each feature has to have geometry. That includes both a type, so whether it's a point, line, polygon, and of course its coordinates themselves. And then each feature also has various other attributes and properties. These vary widely depending on the data. So now we're going to talk about some of my favorite Python packages to use to deal with this problem. Fiona is the first one that I really like. And what can be really awesome when you're making a map, there's great free data all over the place. Natural Earth is a great place to get simplified world data, countries, nice cartographically lined up, and a lot of interesting attributes, but it's usually not in a format that I like. So let's say we want to change it to GeoJSON. So after you download your data, you just create a really short script, and with Fiona, you can open it up. It automatically figures out what it needs in the open part, but then when you open up your output file, you need to tell it, okay, which coordinate system am I going to use? What's the schema? So that includes the geometry and the attributes. And what do you want to turn it into? So here we're saying we just want to use the same as the input for the coordinate system and the schema, but we want to change it to GeoJSON. And then for each feature in that original file, we go through it one by one and say, okay, as long as it's not Antarctica, let's keep it. And you can also filter by bounding box. So if you want the Eastern Hemisphere, Western Hemisphere, much smaller, bigger than that, you can do that really easily with Fiona as well. Yay, data. Another great Python package is PyProj. So say you, projections can be a problem. That last one, actually not super pretty, especially at the top and the bottom of the poles there. If you're tracing great circle routes, if you are making a map of the poles, you definitely need to use an appropriate projection. PyProj works really well with Fiona to do that. So in this example, we are going to go ahead and pull in the schema from the original file, but then take the coordinate system and put it in a projection object. And then after we open it up, the new one, and say, okay, I want it to be in projection 2163. That's a code, an EPSG code. You can look these up. These are well-known codes for all kinds of different projections. And then get it ready to go by putting the output projection in a projection object as well. This is where it gets kind of weird. Natural Earth data, some of it is polygon, some of it's multi-polygon. So multi-polygon is kind of higher level. It can contain a number of polygons. So in either of those cases, you need to treat it a little differently because the coordinates themselves will live one level deeper. So depending on whether it's a polygon or a multi-polygon, you use the, you kind of stack it up a little differently, but in either case, you use transform, which is from PyProj, to change every single coordinate one by one from the input projection to the output projection. And then you can get something like this. It's pretty awesome. One last Fiona example. So I am a real quantified self geek. I wear a Fitbit. I track all my bike rides. I've never bothered to visualize them all in a map before, which is kind of silly because I make maps all the time. One of the biggest problems is that I have all these separate tracks and I've downloaded them all separately. And I just want to do it once. I don't want to do it over and over and over again. So this example takes a whole bunch of GPX tracks, puts them in a single file, makes it a lot easier to map. So here what I do is I grab one example file and grab the coordinate system and the schema from that. And then I set up your normal kind of directory walking operation, pull everything that ends in .gpx and read through it and add it to this final file. So then I'm able to make a visualization like this where I find out that I really don't do much but go back and forth to work all the time. But that's okay. But before we go any further, let's talk a little bit about GeoJSON. So why do I keep turning everything into GeoJSON? It is JSON for geodata. It's super easy to use for web mapping. Web mapping libraries generally love it. And it's really easy to parse with Python because really it's just a dictionary. So here's kind of a weird example. I have to talk about OpenStreetMap because I'm on the board and I love it. OpenStreetMap is great because it's a lot of free data, crowdsourced, that you can get from all over the world. It can be really hard to find this kind of data anywhere else. But the data structure is really weird. And you get everything all at once. So let's say I'm planning a trip to Japan, which I usually am planning one, whether I'm going or not. And I want to check out all the buildings in this area that I'm interested in. You can just download them from the OpenStreetMap website, but you're going to get everything. You're going to get all of it. You're going to get the streets. You're going to get the state, the country of Japan. You're going to get all of this by selecting this area. It's kind of crazy. There are a number of ways to convert it over to GeoJSON, but really it's just XML data, so you can dig into it with your favorite XML parser if you like as well. And then process it. So the reason why I love GeoJSON and why I picked this example is you can just play with the data and keep exactly what you want, what you don't want. You don't have to use any libraries at all, really. You just load it up by using JSON loads. Here we're creating a feature collection dictionary that is going to be valid GeoJSON when it's all done. And then we are going to loop through all of the features in that data set, check all of the tags in it. So the way OpenStreetMap represents its attributes is by having tags for everything. So a building with a name is going to have a building tag with some value and a name tag of some value. So I decided that that's what I wanted. So I check if there's building in there, if there's name in there. Let's go ahead and move on. So then we're going to grab the ID, pull the name out of the tags, grab all the other information we need, and then create, with those variables, the final GeoJSON version that we want. So we're going to put the geometry where it belongs, the coordinates where they belong, keep name outside of tags, and keep all the other random tags in this separate tag dictionary. And go ahead and add it to our final file. And all you need to do to create that final GeoJSON file then is do a JSON dumps. Then you can get cool stuff like this. And these are all the buildings around Shinjuku, but I should have gotten the ramen shops instead. That's what I really care about. You can also do similar operation with CSV or XML data too. All you need to do is put it in a dictionary and then put your GeoJSON together. So I do this with all kinds of data sets from all over the place. And I'm able to make it so at the end, I have only the features and the attributes that I want. I don't have a bunch of other stuff that I don't need. If you have a lot of data, you can switch to reading and writing line by line by keeping kind of dictionaries one line at a time. And I've done this with the whole OpenStreetMap planet before, several gigs. It was probably not a good idea, but it worked. It was great. And because it's just a dictionary, it's really easy to create tests for the data. You can check for required keys. So say your database that's going to keep this data and use it for something is expecting certain keys to be there. It needs to have a boundary type string that represents the data source. You can check that each key's value is what you expect it to be. You can check against a list of known values. So say there are only a certain number of trusted sources, or your filters are expecting certain values. You can check and make sure that's all set ahead of time. You can check the structure, how deep do the dictionaries go, and check to make sure the geometry is valid so you don't end up with null island. So this is really important if your system is expecting a very, very particular format while your data comes from a variety of sources. So at UA, we get data from all over the place. We get Maponics data, we get OpenStreetMap data, we get a bunch of random stuff that customers give us, and it all needs to be in exactly the right format, every single feature or production incident. And after I did that once, I was never again. No more production incidents. So I created this set of tests really easily just by going through the dictionaries and checking for the things that matter. Also, you can use Shapely for spatial analysis and data manipulation. Shapely is a super powerful little library. There are tons of examples in the manual. I made this wall of text just to kind of show you how many things it can do, how powerful it is. You can construct geometry, simplify it, create buffers, merge, union, check distances between things, get symmetrical difference, see if one object contains the other object, on and on and on and on. It even works with 3D data and Numpy. There's all kinds of stuff that you can do with it. So remember those GPX tracks that we put together earlier? Well, some of them, it turns out, I didn't show them, but I have a bunch in California. I don't want to deal with them. I don't want to deal with my flight to California either. I want just the ones that are in Portland. I don't want to go through them one by hand. So what I did first, you just get your city as GeoJSON, and I read Portland on in and put it in a Shapely shape object. Its geometry, that is. And the same thing, for each of the tracks in that original file, I read them into Shapely shape objects. And then I was able to do this really easy line here, check if the geometry of that track is within the convex hull of Portland. Yeah, we're going to keep it. I use the convex hull because there's a little known, very small city called Maywood Park that was formed when nobody wanted a freeway built through it. And my tracks would have been excluded that passed through there. So I got the convex hull, which is the smallest polygon that would contain everything within it. Then you just write it out. So it kept all the stuff in pink, not the plain tracks in beige there that I didn't want, so that's great. Another great option for geoprocessing without GIS software is PostGIS. And that is an extension to Postgres. As many of you probably know and already love, you can talk to it with PsychoPG2. It works really well, and you can run spatial operations directly with that, and it works surprisingly well. Finally, GIS software loves Python. ArcGIS, Esri, I think, is actually a sponsor of PyCon. Has a really cool Python community section set up. They really like using Python for scripting. They set up their own ArcPy module that does all the tasks within ArcGIS that you can script them together, create tools and add-ins with them. QGIS is kind of the closest open source alternative to ArcGIS, and it has a Python console. It also has a QGIS module that you can import from outside of QGIS. So you can have a third-party app that brings in the QGIS UI or geoprocessing tools without actually having to run QGIS, and that's cool. And development too. QGIS is written in C and in Python, so you can contribute to the development of it directly. There are more than 250 plugins already for QGIS, and they're all written in Python. You can do all kinds of really, really interesting stuff. This one is a 3D export. Helps you make a 3D map in a web browser with WebGL. So actually, I talked way too fast, and I think I'm way under my time. So I think I'm just going to open up for questions at this point. Thanks. Oh, there's a microphone over there if you need. Thanks.
Hi, thank you very much. I'd like to ask if you would mind putting your first slide back on so we can copy your website.
Yes. Sorry.
Thank you.
Sorry. There we go.
Hi, thanks again for the talk. I've used OGR and GDAL, and I'm not familiar with Fiona. Can you talk a little bit about the differences and
so Fiona actually uses OGR and GDAL, or Goodle. People say it either way. It's just a Pythonic kind of interface to them. So you do still have to install them, and you are actually using them just in a Pythonic way.
Hi. Great talk. Thank you.
Thanks.
I'm working on a project that it's ocean modeling. So the results that we get have lat and long data in them. We've also got currents and stuff. We want to work with social scientists that use GIS. So we've got data in netcdf files.
Oh, God.
They want shape files.
Okay.
Do you have any recommendations on how to do that?
So OGR, what the guy in front of you brought up, can do almost any translation. Fiona works with a lot of the OGR. Sorry, now the word's escaping me. A lot of OGR drivers. Fiona works with them, but it doesn't support all of them. I'm not super familiar with the format that you netcdf or. Okay. Yeah, I haven't used it before, so I don't have any particular tips for that. But
yeah,
my go-to is OGR, which Fiona uses, but doesn't always support all the drivers of, and that's just really easy command line. I mean, not really easy for people that are afraid of the command line. It's definitely not easy, but once you kind of practice with it, you'll trust it. It usually does the right thing.
Okay, thanks.
Hi. I'm not sure if you addressed this, but I was just curious about the biking data. Like, what format was that in? And also, what did you use to visualize the bike data?
Yeah, totally. I can talk about that. I skipped past it because I was like, I'm not going to have enough time. And then I had a ton of time. So this is actually not biking data. This is all of my data from walking all around and traveling around Portland. I use an app called Moves. And it basically tracks me all the time. And this is like a few months of Moves data. And so Moves luckily has a pretty friendly API, and it plugs into a lot of tools. There's a tool called Moves Export that I use to download a week of data at a time because I didn't want to deal with having to download them all individually. So once I had every week as GPX data, so I was able to download them as GPX data. Fiona can read, there are actually several layers in GPX data. Tracks are just one of them. So you actually have to tell Fiona, okay, read the tracks layer. Don't read the waypoints. And I think there are a few others. But once you have that, and it's all thrown together. So this is done with TileMill, which is a neat, I don't know if it's open source. I think it's open source. It's put out by a company called Mapbox. And it's on top of their tiles here, and you use something that's actually called Carto CSS to style it up and do some composite operations. So I did a multiplying composite operation, so it would be darker the places that I went more. If you want to know more about TileMill, I think you can just Google TileMill or Google Mapbox, and it's really easy to get started with them. I'm a big fan of Mapbox.
Okay, thank you.
Yeah. Cool. Anything else? Thanks, guys. Thanks for coming out to the talk.